Start recording. We should be rolling now. So again, good morning. Okay, so this is lecture 1 of the natural language processing with deep learning. And my name is Ivan Habernal. I'm a professor of trustworthy human language technology sitting in the next building in the 5th floor. And well, we should start maybe first with the motivation. So why are you here? I mean, why I'm here, it's my job. Why you're here, we'll figure out. So that's the first question we have to address, and then we'll talk about other things. First question, can you hear me in the back? Is okay? There's no microphones, unfortunately, so I have to be loud. If you don't hear me, there's very few premium VIP seats, so just move forward. So why should we study deep learning for natural language processing? So this is an interesting question. So if I ask you like, why are you here? We have some chat before, so why study deep learning for NLP? There's many reasons. I think like there's two camps here. Maybe like the typical answer will be that you're gonna build another AI startup to get filthy rich, which is you, for example, I guess, and maybe other people. And maybe there's another camp saying like, you need to get a skill set. So if the AI will take over the world, you know how to destroy it, right? So who is in the camp A? Camp 1, raise your hand. Yeah, raise your hand. Be proud of it. I mean, if you get rich, like, be okay. A few people. Who is in the camp 2? Wow, interesting. What? So I'm guessing you're like, computer security people. No, not really. Yes, okay. Well, okay. Well, and the rest. Well, the rest is maybe here for. It's interesting to study these things for. Also from the research perspective, because you might want to be doing research on safety or security of large language models, LLM. Maybe privacy, this is what my group is interested in. Fairness, maybe some agentic AI, building stuff which can do things. Green AI, like you don't want to burning too much coal for running AI, so you want to make it more efficient. Domain-specific LLMs and things like that. So. If you can find yourself here, you're on the right spot, and maybe you have different reasons why you're here because you say like, well, maybe it's just interesting, which is fair. So I don't want to. The good thing now is like I don't have to tell you what's AI because you're probably using it more than I do. Like who is using? Okay, so raise your hand. Who's using ChatGPT on a daily basis? Okay. Is there anyone who's not using ChatGPT or any LLM just for a reason? Okay, wow. Why? That's cool. I mean, that's cool. Why? Say again?
Because I do research on that area, and let's just say, you see how many ways go wrong.
You do research on this area, and you see how it's wrong. Okay. If you do research while you're taking this course, by the way. Ah, okay. Oh, very cool. Very cool. The back row. You don't trust it; it's stupid. Okay, yeah, sure, yeah. I'm in the same. I'm in the same boat. Yeah, surprisingly, I'm doing research about this, but I use it very rarely because I don't know. I'm considering myself old school too. Anyways, so that's why we're here. What we're gonna be talking about in the next semester, like 13, 14-ish lectures and exercises, is not important right now. So if you want to look it up, I will change this. I mean, I will remove some topics which are maybe more. Not that up to date and add something more on contemporary LLMs and transformers later on. But I guess like the first 4 or 5 lectures will stick to this thing. So what's interesting, we won't start it with like I think like every machine learning course starts with I don't know, let's minimize a function and let's have some fancy mathematics and stuff like that. Is it like that's what I usually see? We're not gonna do this. We're gonna talk about NLP tasks and evaluation. Because it will set up a frame for why are we doing this? Why is it important and why is it hard? Like, why should we bother with natural language processing in the first place? And what can we solve with that except for, I think like you have a gist what LLMs can do in these days, what can you do with ChatGPT? But there's just much more, than just, I don't know, like asking for, helping you with the assignment, So we'll figure this out. So, but before we jump to this topic, there's some course logistics for today. So, there's lectures and tutors, which is me. So I'm doing the lectures and I'm also doing the exercises. So the exercise is taking place in the afternoon every Thursday, 2 to like 19 minutes from 2. Does it work for everybody? Starting at 2 sharp, not 2:15, like 14:00. Is it okay for everybody? Awesome. There's some people who have conflicts in the schedule because there's the other course, something development of AI, things like that. Is it your case? So how many people are taking the other course? I'm just curious. A few. Okay. It's up to you to choose. I mean, sure. The exercises will be published on the GitHub anyway, so feel free to do them on your own. I'm sorry for this, but I didn't know this. I didn't talk to Bilal, and I think he put it like on this, in this slot. We didn't align on that, so sorry. Okay, so lectures, exercises, the resources. So, well, there's no homework. Okay, we'll come to that. But announcements and forums. So we're using the Moodle. I think everybody's since signed up in the Moodle. If there's some sort of like official announcement, for example, I don't know, I'm sick, I can't do the lectures or whatever, I'll post it there because everybody should get an emails from Moodle, I guess, right? Are you getting email from Moodle? Excellent. We have this GitHub. I mean, Moodle is great, but it's very old school, so we won't use it for anything else than just making announcements and maybe some forum if you really need to. If you need to contact me, there's this email, which is great. We'll have GitHub for lectures. And here's it's an option. It's always worked well. So are you on Discord? Okay, who's against Discord, like by choice? Oh, that's great. Okay, so I don't care about privacy on talking about research, so Discord is a platform. Okay, so I'll set up a Discord channel, and then it's much easier just to discuss things, and you can discuss things among yourselves, but mostly like the top number one post on Discord is like what's going to be in the exam, and people start asking this like roughly after Christmas, and then you see like, oh no, so, and 100% sure we will see this message in there. So you don't have to write this question because we'll come to the exam later. But let's use Discord for whatever. If you have questions, you can get in touch. And I'm gonna hopefully, if OBS doesn't crash, I'm gonna record the lectures and put them on YouTube, which doesn't mean you can just sleep longer and don't come here. Like you can watch this on YouTube, absolutely, sure. I have no objections. But the idea of these lectures is being a little bit more interactive. So I hope it's gonna be interactive enough that it's engaging for you to come over in the very early hour for some. But hey, I mean, if you made it 10 a.m. and you had a lecture and you learned something already and the day just starting, so maybe it's a good thing. Yes, you have a question?
Do you also record the exercise?
No, I don't do the exercises because it's not worth it. So no, I mean, it's just a little bit self-critique, but the exercises are sort of like we're hacking things together or doing some crazy stuff on whiteboards maybe or things like that. I don't do this. And I put a solution. I mean, the exercises basically are for you. The solutions will be also published maybe a week later. So if you struggle and have questions, then ask. Sorry. Yeah, I think like you can put anything on YouTube, but I think like you can also don't have to put everything on YouTube. So
I just asked because of the other course.
Yeah, the other course. I said like the exercises are not super important to be in person, I would say. But it's more interactive. But I would say like if you want to sacrifice something, sacrifice the exercises or the lectures. Okay, any questions so far? Sounds great. So we have premium seats, first row, but if you feel whatever. Resources, textbooks. Okay, so I don't think there's actually like textbook I'm covering, but I'm borrowing from a couple of textbooks and a couple of actually papers. So I'm going to like the first sources. So if there's a paper I'm citing, it will be in the slides as you will see, and you can look up the paper. All of them are freely available. Most of the books I'm citing now are also freely available, or you can get them through the library here. I mean, not library. You don't go to the library for the papers, but through the university network. And top-notch research in natural language processing is basically like open source or open license accessible. So there's paper in the so-called ACL anthology, so aclanthology.org, and many papers are published at arXiv, and we're using papers from some journals and conferences. I'll always put a link, and they're easy to find if you want to dig deeper into that, okay? Good. So far, so good? Cool. Exercises. Deepen your understanding of the matter, mostly hands-on. It's not graded, okay? So exercises, I mean, everything is kind of optional. The only thing which is graded is the exam, but nothing in between. So exercises are just for you to learn something by doing. And we're trying to refurbish the exercises right now. So the goal is that for each exercise, we provide, we meaning me and Yasin, which is the student research assistant helping me with the exercises, we'll provide sort of a guidebook PDF for the assignment. So the guidebook is something you can, like 2-3 pages of PDF, which you can just refresh and read the stuff for the exercise, so you know what to do. So you don't have to like start Googling only, okay? And some, mostly it will be some coding and sometimes pen and paper things, but less. I think we will be just coding mostly because it's fun. We'll figure out today in the afternoon, okay? One warning, the room for the exercises is horrible. It's a GAFO to something. So first, it's super hard to find, even if you are like, if you know the dungeon here. So this is in the, in the labyrinth down there. So take some time to find this room for the first time. Second, there's no power outlets, so you charge your laptops. There's few of them. I mean, we can get some cables, maybe like a Verlängerungskabel, but in my experience, it kind of sucks. And apart from that, the chairs are bad too, but it's okay. Yeah, I mean, it's not ideal, sorry. This would have been much better, but that's how it works with rooms. So you've been warned. And it's not my fault, I'm sorry, in advance. Okay, exercises. Any questions? Yes. Yeah, okay, so exercising do start today, yes. We'll meet at 2 in the afternoon, sharp. And where's the GAFO? Okay, so there's north, south, this direction. You cross the green part, the park, and it's one of those buildings downstairs, down there. And GAFO is, campus plan. Look up on the internet like the plan of the campus. You'll find GAFO somewhere, and then you have to go. You have to go in, left, down, door, up, turn around, up, and left. This is the only entrance to the building, to the lecture room. It's very complicated. You'll find out. I mean, you'll manage. But the university campus plan will help you. GAFO. It's on the campus, like across the park. Okay. Any other questions to the exercise? Awesome. Final exam. So the first date for the final exam is February 11. Somehow in the morning, like 9-ish, 9:30-ish. It will take roughly, I guess, like 90 minutes. And it's an electronic exam, e-assessment. So you made, okay, raise your hand if you did Introduction to AI. Okay, yeah, so there was an electronic exam. How did you like it? No, you didn't. Why didn't you like it? I mean, why? That's a good question. Yes.
Because there were too many teachers.
Oh no, I'm not asking about the course. The course is. I'm recording. The course has some flaws because of the constellation of the course, but the exam, the electronic exam. Yeah, it's okay. Good. We'll do it. Last year we did it as well, and there was a lot of hassle because I asked for some drawings and people cannot draw with the mouse, which I can understand, so sorry for that. I'll try to make it as text-based as possible, but there might be some drawing and equation, so if you want to practice something for the exam, practice drawing with the mouse in Microsoft Paint or whatever that is. But it should be just a rare, should be minimum. But some people weren't able to draw even like a square. Okay. Exam questions. So everything is in English. We're teaching in English. If we have questions, you can ask in English or fall back to German. I'm fine with that as well. So it's up to you. The goal is to be as inclusive as possible because English is the lingua franca of machine learning, AI, and NLP and computer science in general. Any questions to the exam? Yes. Oh yeah, so this is the question. What's going to be in the exam, and can we see the previous exams? Oh, you mean like a dry run? Yeah, it's a good point. Most likely not, but it's not that hard. Like if you're taking the exam as a student, it's basically Moodle, where you see a couple of pages in Moodle and you just enter things into the Moodle, click on save, and you're good. I mean, this is not rocket science. It should be easy. Like so, there's I mean, like the actual execution of the exam is very easy. Don't be afraid of that. The question is like what's going to be in the exam. We'll discuss in during the course. Any other questions? Excellent, amazing. Because this is your course too. I mean, of course. So your feedback is very important. So if you like what you see, that's okay. If you don't like what you see, then talk to me, either during the lectures, after lectures, on the Discord. You can mail me. What I'm going is like to ask for some feedback every couple of weeks. So I'll send you a couple of feedback forms if you don't, if you want to give feedback anonymously, because I want to improve this course. I want to make it really like accessible and a nice learning experience. So you can build either a very fancy startup and be rich, or you can destroy Skynet, or whatever you want to do. So it should be a good course. So if there's some bugs in the slides, everything is open source. Just open a pull request on GitHub to fix the bug on the slides, and I'll just merge it, and that's done. Okay, everything is free license in a way. Excellent. Next point, something about my group. So we are called Trustworthy Human Language Technologies, which is NLP in a very fancy name, language technologies. And we are mostly doing research in two parts. First one is privacy preserving natural language processing. So what does it mean? Well, what is privacy in the first place in language? What does it mean? Can you protect your training data maybe? Can you make some formal guarantees about it? How can you train models? Can you anonymize text efficiently? And all these things, so privacy and text. And the second part is more interdisciplinary, which is the legal natural language processing. So cooperations with not actual lawyers, but law researchers. So professors and researchers in law asking very crazy questions which we don't understand, but then we bring our stuff into the place and do some empirical legal analysis, for example, finding what the arguments are in the decisions and stuff like that. So if you're interested in any part of this research, get in touch. So we have master thesis once in a while, which we will be happy to supervise. We have I don't know if you call it HIVI or student research assistants or SHK or things like that. So research assistant jobs once in a while. So get in touch. I'll be posting some of those on our Moodle, because if I'm looking for people, I'm looking for people who kind of who I know are taking some courses which are important. Let's put it like that. And this is my email. You can contact me anytime. Any questions? Sounds great. Okay, so now finally coming to the core of the first lecture. So natural language processing, challenges of NLP. So why is NLP hard? And you might think like, well, NLP is a solved thing. Like I have ChatGPT and it understands everything. It can translate, it can, I don't know, generate things, write me an essay, write me LaTeX code, write me everything. So it can't be any challenging, right? Well, it's getting better and better. Language models are getting really better and better, as we will see. But we shouldn't ignore the actual challenges of working with language in the first place. So language is very tricky as compared to other media or other modes. And one of them is high ambiguity of language. So human language is ambiguous and very variable. So here's one example of ambiguity in language. If you compare "I ate pizza with friends," to sentence "I ate pizza with olives," on the syntax level, or sort of like surface level, you just replace one word with another, but the meaning completely is changing, right? I mean, you have very different kind of mental model of things like "I ate pizza with friends" and "I ate pizza with olives," because they're completely different things. Unless you're very, I don't know. I mean, in theory, you can eat pizza with friends, but no. So ambiguity. It's not that easy to move from one meaning to another. Also, highly variable. You can say the same thing, the core message, you can tell in very many different ways. So "I ate pizza with friends" can be expressed as friends and I shared some pizza. You know, friends and I, me and friends ate pizza yesterday, and you can like there's so much variability and variance in language, which is kind of interesting because we are as humans really great users of language. We are really great of using this. This is like one of our main tools of communication is language. And we are very poor at formally understanding and describing rules that govern language. So this is not a critique of the linguistics, but linguistics is sort of trying to actually find the rules that govern language. And it's actually very hard because we don't understand how language works. Like we're trying to describe it like descriptive linguistics. We're trying to develop theories of language, but we actually don't know. And we use it like all the time. And now we're trying to build machines that understand it also all the time. And we don't understand why, how, many times. Many times it's very easy explanations, but many times not. So is there any linguist here in the room? Okay, interesting. So does it make sense what I'm saying or not? Because I'm not a linguist, I'm computer scientist. But you agree? Okay, so approved by a linguist. Awesome, okay. First achievement, awesome. So we're not going to do any linguistics. And unfortunately or fortunately, you don't need much linguistics to understand natural language processing because it's more about like the tools, models, and a lot of software engineering as well, but some sort of linguistics is essential. So if you're interested in linguistics for NLP, there's 2 serious books from Emily Bender. She's a professor in the University of Washington, I guess. And it's called Linguistics for Natural Language Processing or something like that. So it's a very tiny little book and you learn the linguistics which you need if you're really interested in linguistics. Highly recommended read, and I think you can get it for free through the University VPN. Okay, let's move forward. Language is challenging for machine learning for many different reasons, but there are some 3 properties. So language is discrete, compositional, and sparse, and we'll touch of each of them in detail. So language is symbolic and discrete sort of signal. So the basic elements of written language are characters. And characters, as you might know, they form words. And words kind of refer to objects, concepts, events, actions, things, ideas. And characters and words are discrete symbols, right? I mean, words such as hamburger or pizza, each of them evoke some like mental representation. If you hear hamburger, you know what it is. If you hear pizza, you know what it is. I don't know, and maybe somebody ate pizza yesterday with friends. Even that. So, and you have some mental representation. But these are distinct symbols, and the meaning of these symbols is external to them. I mean, it is something you interpret in your head. If you see the word pizza, it's just a couple of letters, but your mental model is telling you, oh, it's very kind of, some food and has some taste and things like that. And the thing is, there is no inherent relation between hamburger and pizza that can be inferred from the symbols or letters themselves. Look at it. I mean, if you look only at these characters here, hamburger and pizza, you know it's food, you know that tastes good, it's trash food sometimes, but it's not in these characters. You have to build your model of your understanding of that. And the relation between these words, it's in our heads. So that's kind of hard to work because, in other domains such as colors, for example, or acoustic signals, the concepts are continuous. So for example, if you have a colorful image and want to put it into grayscale, you can just use a simple mathematical operation. You change the semantics of, not semantics, but you change some properties of the image by turning RGB into just 255 bits in grayscale, and that's done. It's like mathematical operation. And you can compare 2 different colors based on their inherent properties, such as the intensity or hue. So there is some continuity in the signal you're having, and it's easy to operate with machines. But this cannot be done with words. Like there is no simple operation to move from the word red to the word pink. Can I ask you for a closer draw, please? Thank you. There is no operation from the word red to the word pink. I mean, these are colors. They should be close to each other somehow, right? Red and pink, maybe. But there's no mathematical operation you can compute the distance yet, inherently. I mean, we have to build something around it. But at the core, these are just 2 distinct elements and they have nothing to do with each other. Okay? Any questions? Does it make sense? Okay, so that's kind of hard. Like, how do you want to work with this? They're just words. There's lots of words and characters. How can we understand them as machine? Good. So next item is the compositional of language. So as we saw, letters build words, they build phrases, we build sentences out of that. And the thing is that the meaning of a phrase, can be larger than the meaning of the individual words. And the meaning actually has some set of intricate rules. And one example are these multi-word expressions. So for example, like idioms, multi-word expressions. So New York, look something up. Like New York is one concept, which is a city in the US, but it's not a composition of words new, which is some adjective of something which is not old, and York, which might be a name. Like you cannot compose these two together and get New York. New York is a concept, right? But it's built from two things. Or idioms like look something up. It's to search for something. But look and up, if you build meanings of these two things together, it's completely different meaning. So it makes no sense. Exactly, you look up. But look up means like to search somewhere. So, it's tricky. Or idioms like kick the bucket means to die. Or blue chip, what is it? Blue chip, I think these are some stock market of companies or something like that. Yeah, some like Apple and stuff like that. Yeah. Which doesn't make any sense. If you don't know the idiom, like you would never find out from blue and chip. So to interpret a text, we need to go beyond the level of letters and words, and we have to look at long sequences of words such as sentences or even complete documents. Okay, so if you want to build machines that understand language or can work with language, we have to go to as bigger context, let's put it like that, as we can, because the meaning of things is in the whole thing, not in the individual letters, not in the individual words, maybe in the phrases, most likely in the sentences, most likely in the whole entire document. So this is why it's tricky. And now it's getting more trickier, because if you think like, okay, well, I can build programs that can kind of, if I see a sentence A, then I do something. If I see a sentence B, I do something else. Sentence C, I do something else. Very easy. But we have sparse data. Because if you think about it, combination of words to form some meanings tends to go to, well, not infinity, but it's very, very large. Like, how many words are in the dictionary of English? How many words? Ideas. How many words could be in English dictionary? 50,000. Okay. More. 100K, maybe 200K, maybe 200,000, depending on the size, depending on how you define word, depending how many domains you plug in, but it could be a couple of 100,000s. How many words are in Duden? Is it less, more? Have you ever seen Duden? Like this is this thick, like, well, I think like it's a couple of 100,000. Yeah. You have some estimate? No, sorry, you, second row. Yeah. Yeah, you didn't know. Okay. Okay, can somebody make a quick check? Google for how many words are in Duden. Yeah. Under 51,000 in the general one, I guess. And if you get like Duden for law, and there's even more. Because of German forming nouns, compositionality, and everything. And then if you think about morphology, like morphologically rich languages, such as the Slavic languages, Finnish, Hungarian even, these are extreme. Like, the words are just extreme and infinite numbers of things you can do with words. And then you have to combine them together. So 150 times on the second position times 150 times K on the third position. It's really growing, well, not exponentially, but yeah, it's actually exponential. Yes, you're multiplying by the number of 150Ks. 150Ks to the power of the length of that. So it's not exponential, but it's growing very badly. Actually, exponential in length. Yes. Okay, so long story short, we could never enumerate all possible valid sentences. That's the hard part. In colors, you have like 60 million colors of a pixel, or 200, I don't know, like 60 million or more. But these are colors, you can work with them. With words, you can do that, but with sentences, you're kind of doomed. You cannot ever enumerate all these sentences in the language. So you have to find rules how these things work together, and if you want to build machines that understand the meaning of a sentence or document, you cannot just write, if you see sentence A, this is meaning ABC. That won't work ever. So this is also challenging when we're learning from examples, because we are, even if our example set, let's say for training in machine learning, if it's very huge, we are very likely to observe events that never occurred in the example set and that are very different. So we might be getting a bunch of training examples, let's say the entire internet, and still, in the entire internet, most of the sentences we will never see. Like most of the sentences you can think of, giving the dictionary, they don't exist. Because of the distribution, I mean, we're using mostly, there's some law, like Zipf's law, we're using mostly, the most common words are using, so we're using words, some words more often than others, which means like we form some sentences more often than the others, but there's a long tail of things that actually could be just once or two times or not at all in your training data. Okay, good. Any questions? Do you see the challenges? So who is with me? Like it's much more challenging now than I thought. Oh, okay, yeah, okay. Okay, I didn't convince you yet. So I mean, maybe I'll convince you, or you'll be convinced, by trying and trying hard and failing, like to do some stuff with language. So now let's say this is like a generic thing. We're leaving linguistics for good for now, and then let's talk about solving some tasks. So let's talk about some typical tasks in NLP. And the idea here is to show you like how NLP is thinking about language, solving particular properties of language, understanding most likely, or generation of language, and also what are the typical benchmark data. So if we talk about a task, then you will have some mental model. Oh yeah, I've heard this before. So it's not like you have to learn this by heart. Some of the things you should know, but just to get you like the landscape of what's out there and how people are actually trying to build models and prove that they are actually somehow capable of understanding language. So this is it. Because before we start talking about deep learning, I mean, deep learning is a tool. It's like machine learning tool, and we need to understand why we need this tool in the first place, and also like how do we know that we have the right tool? So how do we know that the job is well? I mean, for example, this is an interesting example. So you mentioned like you don't trust LLMs because they're producing rubbish. So how do you know it's rubbish? Because you know better. Because the answer is like, yeah. I mean, if you ask ChatGPT like, what is 2 + 2? But you will never ask this question. So you will ask something like which you're interested in. And then sometimes you see it's producing good outputs and sometimes it's producing bad outputs. Can you quantify it? Can you generalize it? Well, sometimes. You have some your mental model, right? Like gut feeling. Yeah, but gut feeling is not enough for doing research, so you have to have evaluation, like proper evaluation of the capabilities of tools we're building. And we're gonna touch this in the second part. But let's talk first about the different NLP tasks. So excuse me. So roughly the distinction into task in NLP is text classification and text generation. Later we will see we can merge everything into text generation, but we'll start with this sort of like classical distinction of task because this makes things much more easier to understand and to begin with. So let's start with text classification. If you just hear text classification, you know what it is. Like you classify a text. So you take a document, and maybe you have different classes. Let's say, maybe given on genre. So sport in the news, like sports, politics, business. What else? Let's say these three. And you are given a new document. might want to build a model that kind of tries to classify it into each of these categories, for example. It's a very stupid example, but it's been a case like, it was a case like 25 years ago. But for example, like spam classification. It's a typical classification example. You get an email and you want to build a model that classifies into spam or not spam. Mostly based on the text, but also very mostly based on some other features of the email, like who is the sender, who is the recipient, and things like that. But it's also based on the text. So you're classifying documents into one of these categories. Okay. So here's one typical, like I would say, like litmus data set. If you're trying to build a model for classification, you should try it on this sentiment classification of movie reviews. So we have there's an example of this data set. So these are movie reviews from the IMDb. IMDb, everybody knows, International Movie Database. So there's reviews, and this is actually the shortest review I found in the data set. So this is a review of a movie. Read the book, forget the movie. And the idea is to predict the sentiment of this review, whether it's labeling the movie as like negative or positive. So it's a good movie or bad movie. In this case, obviously, the book was better, the movie sucks, so it's a label negative. So it's a binary classification, and if you did any machine learning before, who did some machine learning before, by the way? Raise your hand. Yeah, okay, so it's binary classification for those of you, those of you who haven't heard that machine learning, like binary classification is they assign one of two labels, typically 0 or 1. And you have to decide what is 0 and what is 1, and that's it, basically. So why is this task important or interesting? Well, you have to understand, because if you look at this example, there is nothing saying the movie is bad. No, it's just saying like, read a book, forget the movie. So you, as a machine, have to understand what it means to read a book. It's a command. So you have to read a book, which is like, which is giving preferences. The book is better maybe than the movie, and forget the movie is like, yeah, you should come back. You have to interpret many things and know what it means about a movie to understand that the label is negative. So there is no word actually signaling the movie is bad, right? Any questions? Okay. So I'll be referring to this data set a couple of times. So this is the IMDb sentiment, movie sentiment classification task. And there's some training data, 25,000 reviews for training and 25,000 for testing. And the testing is basically, yes, you need to evaluate like how well your system performs on classifying things that haven't been seen before during training. We'll get to that. Where do you get the data, by the way? Where do you, if you do any experiments, where do you get the data? Stealing from somewhere else, exactly. So do you know, you're doing if you say you're doing research, right? So did you say you're doing research? No, that was equal. Oh, yeah, okay. So you're not even doing research, and you still would be stealing from somewhere else. Yes, yeah. I mean, but that's not stealing. Like for research, you're borrowing in and show some research. That's okay. We can do this. Do you know where this data set comes from? I mean, obviously it comes from IMDb. So how this has been constructed? Yeah, somebody scraped IMDb. If there was like 8 stars plus, they call it positive. If there was like 2 stars and less, they call it negative, and that's it. And subsampled from this data and publish this data set. And why not? So where do you get it nowadays? You don't have to scrape it again. There is this very famous page called Hugging Face, which hosts pre-trained models and data sets. So you can get most of the typical data sets from Hugging Face with a simple API in Python, and you don't have to do anything. You have everything prepared for you, okay? So, or you can, if you create a new data set, that's a different question. And you shouldn't steal data. Wow. Okay, we'll get to that. Nice. You're the first camp. I get it. Okay, I get it. Yeah, that's tricky. How to get rich without stealing? Yeah. In capitalism. Okay, cool. I don't want to be banned from YouTube. Okay, so let's stop this and let's talk about natural language inference. So this is another task, another data set from Sam Bowman and the last author, Chris Potts, Chris Manning, 2015. I think they won best paper award back then, I guess, for this data set. And this is another task where you have, if you look at the example, so there's a text, a soccer game with multiple males playing. So it's basically describing a picture. And there's another text called hypothesis. Some men are playing sport. And the goal is to say whether, if you read this first sentence, you would say the second sentence is true, which is called entailment. So the first sentence entails the other. Or it's contradiction, or it just doesn't have to do anything with that. So this is entailment because if you read a one, the hypothesis is true. If this were some women are playing sport, this would be contradiction because we're saying here a soccer game with multiple males playing. And neutral would be like, okay, the cute cat is sitting on the mat or something like that. Okay, so this is the data set, and it's sort of like standard natural language inference paper. And the difference from IMDb is that here the data was actually annotated. So IMDb, they stole it from the internet, like scraped IMDb. This paper was actually creating all these 500,000 examples by they paid crowd workers to do this. So it was really costly to create this data set. So any questions to this task? Entailment, SNLI. I'll be using this in the lectures as an example later on, so that's why it's here. But the question is like, I mean, we touched this already. So how to get the gold standard data? So many data sets are actually annotated by experts, and it's actually super costly. So one example is, shameless plug here. So we annotated something with the legal experts, and there were actually like law researchers, postdocs, and master students, I guess. And we are paying 8 students for a year. They were annotating some data. So it took a year to annotate a data set. And they really spent a lot of effort and time. And we spent 20,000 euros on that, on the data set. So this is how you get rich in research. If you don't want to steal, you have to pay people to do data for you. For example, if there's no other workaround. And if you create a new data set, you also want to see whether so we call them annotators. So the experts who are actually labeling the data. Okay, this is, for example, if we are annotating the movie reviews, each annotator would be saying, oh, this movie is positive, this movie is negative. But they might be wrong in some cases. So you want to have the same data point be annotated by at least 2 people. So you can then compare whether they agree or disagree with each other. And for that, we're using some sort of inter-annotator agreement scores. So this is optional for you, but if you ever stumble upon that, like the quality of the data set is also determined by how objective that is. Because if everything is super subjective, for each document, 2 people say something completely different, then there is a problem. Like, what is the truth? We'll get to that later. Okay, any questions so far? Sounds good. We tackle this. Who creates these tasks and why? I mean, mostly researchers. And mostly for phenomena in language to show that, can we actually solve them? And what is very important, that these data sets are shared. So you share the data set with other researchers, and because you want to compare apples to apples. If you're saying, I have a new Llama 5.6, which is better than anything else, Gemini, and things like, yeah, so then I would say like, oh, so show me some benchmarks, and can you objectively say like you're better? So you have to have the same benchmark, and we'll come to that later. You should never test on your training data. Okay, so if there's something you have to remember from this lecture, never test on your training data. I will repeat this like maybe 5 times later in the lecture. But you use sharing basically data sets to be objective. And these categories are sort of like arbitrary. So there's no like cut in the stone taxonomy. So for example, sentiment analysis is part of text classification. Natural language inference is sort of like sentence pair classification. So you have the text and hypothesis. So it's a pair of sentences, and you want to make a label between those two. And there's other tasks. So one of those tasks go deeper into a sentence, and it's called NER, named entity recognition. And it's very easy, simple task. So you have a sentence which reads here from top to the bottom, some sort of news. UN official Ekeus heads for Baghdad. It's very much early 2000 newspaper. And what you're trying to do is that for each word, you're trying to label it with some sort of entity label. So either it's an organization, United Nations, Ekeus is most likely a person, heads for Baghdad, which is a city. And so you want to find entities of predefined task. So how to model and annotate such a task? So let's say you have a data which is not annotated, so what you're going to do? So you want to classify each token into, I mean, we call these tokens, right? So it's token, 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 token. And you want to label each token. So typically what we are using is so-called BIO tagging. BIO, which is beginning, inside, and outside. Or sometime EO tagging, inside and outside. It's very simple. So for each token, you assign a label. So here's an organization. So you say IORG, here's no label, person, no label, location, no label. So basically it's like token level annotation of a task. And what you're trying to predict then is exactly these the sequence of these labels for each token. So it's not like document classification, but you're classifying basically each word in the document. And of course, you want to take the context into account. So you take the whole sentence and and you try to predict the whole sequence of these labels. Does it make sense? Any questions? Okay, we're good. So there's some tricks here in the BIO encoding, which is not important for now. Yeah, I mean, if there's two entities starting immediately next to each other, then use these B tag. But this is how they did it back in the early 2000 for this shared task of entity recognition. And this is like multi-class classification on the token level. So this is what I said already. So each token belongs to one of these classes, either O or person, IPER, BPER, ILOG, BLOG, and stuff like that. Okay? Does it make sense? Yeah, this is not rocket science. Good. Okay, so there's another. I mean, so far we talked about the sentiment analysis, so document level, two sentences comparing, then in each document, and then people said like, well, I don't want to evaluate my system on each of these separately, so why not take them all together and call it a new data set? So now you're not stealing from the original data, you're stealing from other. No, you're not stealing. You're basically collecting other data sets into one big data set. And one of these data sets is very popular called SuperGLUE. So it's popular benchmark collection of various tasks data set in English. So the goal of SuperGLUE was to provide a simple, robust evaluation metric for any method capable of being applied to a broad range of language understanding tasks. So language, understanding, evaluation, I think G is for, I have no clue, general, generic, gigantic, and super means like there's so many of them. So basically, SuperGLUE has been very popular, like maybe still now. And there's a couple of tasks, including the sentiment analysis, I guess, and then the inference, which you just, if you have a new model and you run it on SuperGLUE, you get some couple of scores and you can compare to the others. And there's even public leaderboard. Have you heard of Kaggle? Who hasn't heard of Kaggle? So Kaggle is basically you publish a task and maybe some training data, but you don't show the test data. So you keep the test data for yourself, the Kaggle. So I'm running Kaggle, I publish some task and I keep it for myself, the test data. So you can train your system, do some evaluation for yourself, then you submit your system and I'll do the evaluation for you and show you like how you scored and put it on a leaderboard. And sometimes I'll also give you the test data because I don't care, but sometimes I just withhold them, so you cannot cheat. And basically you can compare your systems and see like, oh, I'm on SuperGLUE leaderboard number 1 because I have the best system, on the planet now, and I'm just waiting 2 weeks before the new big model just, pops out and will be better than I. So leaderboard. And SuperGLUE basically is a sort of leaderboard. Does it make sense now? Okay. Kaggle is more like machine learning oriented, but some NLP folks are using this as well. Okay, so another task. Wow, good. Question answering, extractive question answering. So here's an example. which I'm not going to read because it's very boring. It's very boring. Some Wikipedia part. So there's a part of Wikipedia about Endangered Species Act paragraph, whatever, some blah, blah, blah. And the question one, which laws face significant opposition? And you have to find whether this part of the text is true or not, and then plausible answer. So basically, it's finding an answer to a question from a given paragraph. And sometimes you have to think deeper. Sometimes it's just, you just look it up and find the answer. So this means you have to understand the whole context, understand the question, and then find exactly what the answer in the given paragraph was. And there are some relevant words which are in bold and could be incorrect. There are some plausible but incorrect answers. So that's the tricky part. You don't want to make the task very easy. You want to make some sort of the traps. And if you just don't pay attention, you just fall into the trap. It's similar. If you do an exam assignment, there is some question answering the same. You want to have some answers which look very easy, but actually they're not. Yeah. Okay, so this was like the part for let's say text classification, because you are already given the option. So you are classifying the document into 0 or 1, positive or negative, or you compare two sentences and say like 3 classes, or saying, well, this answer is correct or not, something like that. So you have predefined set of answers. But think about other tasks which are more, I would say, more common these days because of the LLMs, are text generation tasks. Okay, so who thinks machine translation is solved? Excellent. Okay. Yeah. Mostly yes. Machine translation works pretty well for many cases, many languages, except when it's not. So I took this picture 2 years ago. So I think it's a menu somewhere. I think the original language was Spanish. And if you look here, there's something fishy about the translation. It's a menu. I guess it was like news of the month in Spanish. I don't know if you speak Spanish. How's Spanish-speaking people? How's news of the month? Or like the new things on the menu? Okay. And if you translate it to German, it's not going to be Nachrichten des Monats. I know. But the news, of course, I see the problem because the system translated news as the news as we know like from the media, and just say like, yeah, it's the news of the month, Nachrichten des Monats, which is wrong because it's missing completely the context. It didn't know it's a menu. Of course, Nokia, whatever. So machine translation is still a hard topic for some domains, and some systems actually struggle with that, but it's getting better and better. So machine translation is one of the tasks, and what's actually hard about machine translation is that you have, if you evaluate machine translation, you have so many options to actually produce the correct answer. So here's anybody speaks French? Can you read this for me, please? Because thank you very much. Which you can translate into without fail. He has been concise and accurate without getting flustered. He showed himself to be concise and precise without falling apart. He has shown himself to be concise. Do you agree with all these things or some of those? Okay, good, because I have no clue what it means in French, so I don't speak French. Okay, and the trick is, of course, you can translate the same thing like in very many different ways because of the variety of language. You want to put emphasis of something. You want to make it sure it's like formal or informal. So many ways of translate a sentence. Can you say like there's only 3 of them are correct and the rest is incorrect? You can't. That's the hard part. So machine translation, for example, and other language generation tasks are actually much harder to evaluate than something where you just classify things and you take it for like one category. So we'll come to evaluation of that later, but just to see machine translation is still not solved. Maybe it's solved in some domains. Yes, like works 99% of the time, but for lower resources languages, for example, or some language pairs, it's extinct languages, for example. Yeah, that's kind of tricky. Like translating Bibles. It's actually, there's a task. Bible translation, I think it's like 2,000 languages. Most of them are dead languages, or some of them are dead languages. And you try to translate one Bible to another Bible with machine translation. It's actually pretty tricky, to get good scores. Okay. So another abstractive task is document summarization, which is, as the title says, you get a document that you try to summarize it. So compress the meaning of that and generate sort of like a summary. So a long document, short, few sentences summary. And here's one popular data set, which is the Daily Mail data set, CNN, which is long articles, so 800 tokens, compressed into 56 tokens on average. And as you might see, yeah, I mean, there could be several different compressions of or summarizations of the article, so evaluation will be very tricky. Okay, document summarization makes sense? Any questions? Cool. And before I go to some other, there's endless tasks like for generation, and one of them is, for example, this persona chat, which has been very popular in some domains. If you have, I think there was an Alexa competition. So do you have Alexa? Okay. I get it, yes. I don't think it's any, I mean, it's preferences. But there was a competition that you should talk to the Alexa as long as you can. So like a chit chat. You start, oh, how's your day? Oh, yeah, it's pretty good, it's raining a little bit, And the longer you engage, the more points you get. And I think it's been in competition like for a couple of years. And the idea was like the Alexa should generate something like engaging to you. And it's very similar to this persona chat data set where you have two personas, like two people, which have some properties. So I like to ski, my wife doesn't like me anymore. It's very kind of sad. I went to Mexico 4 times this year. I hate Mexican food. I like to eat Cheetos. So somebody wrote this, and I think it's pretty, it's pretty dark. I'm an artist. I have 4 children. I also got a cat. I enjoy walking for exercise. I love watching Game of Thrones. So imagine these two people meet and they start chatting, and it was written by annotators, like crowdsourcing. So you ask real people to write something and then act as if they were person one. So we started, hi, hello, how are you today? I'm good, thank you, how are you? Great, my children and I were just about to watch Game of Thrones. Okay, it's a stupid data set, well, it's very chit-chatty. But the task is, if you end up here, can you predict the next sentence? What should be the next continuation of this dialogue? So basically, you generate the next sentence. Or how they want to do this is like they make a cut before the last one. No, I don't have much time for TV. And then the second person says something. And it has to be similar to what I try to do. Like this is how it's evaluated. Yeah, so why not? Some people are chatting with ChatGPT just for fun. Are you doing this as well, like sort of therapy? Who's talking to ChatGPT? Like, really? Oh, excellent. And? Is it fun?
No.
Okay, so you're hardcore. Okay, so why are you doing this if it's not fun? I see. Okay, so by you're using like more like, let's say like information search in a disguise a little bit, like, no? Yeah. So it's not like, oh, I'm feeling so shitty today. How was your day? It's not a friend. Yeah, okay, good. Yeah. It's like better Google then in a way. Okay, I get it. Awesome. So, so let's leave persona chat. So some typical generation tasks. I mean, here's a summary again. So we talked about machine translation, summarization, question answering. You can also generate questions. So given, for example, an image, you can generate what can people ask about this. Or dialogue generation, we talked about this. If you go to multimodal, we won't touch multimodal in this course. We will stick to text only, which is challenging enough. But you can get an image and just make a caption of this image, or if you have a table, you can try to generate text and things like that. So these are generation tasks. Sure, but then the thing is you can actually turn classification into generation, and you can say, that's what people are doing with all these GPT-based models. So translate English to German, that is good. This is standard, translation is text to text. But you can ask also the same model, to solve natural language inference, you say the premise is I hate pigeons, the hypothesis is my feelings towards pigeons are filled with animosity, which is entilement. And you know, the model will just produce the word entilement. So you can generate basically the label as a text and then evaluate it as a classification. That's also possible and makes many things easier down the road. But we'll stick, you know, for now we'll stick to the distinction between classification and generation. And later on we will unify that, you know, in lecture 7 or 8 into this umbrella of everything is basically generation if you want. Any questions so far? Good. So, evaluation. We have 30 minutes. That's good. So typically, I won't be touching much of machine learning things, basics, because there's other courses which are doing actual machine learning. There's Intro to AI, which actually talk about machine learning. Yes? Did you talk about machine learning in Intro to AI? Have you trained? Okay, who hasn't heard of train, validation, or test data split before? So everybody knows what is train, def, and test. If you have data, you typically train your model on the training data. You use the validation for saying, is my model good or not? And then before you submit your paper, you first evaluate on your test data. And never go back, because otherwise it would be cheating. Okay, if you're not doing this, think about it. Basically, what the whole idea is that you want to train and validate your model on something which you can improve. There's some iteration. You make your model better and better. But you never train on your test data, or you should never take the information from test data to improve your model, because then you're sort of cheating in a way. The test data should be unseen ever. So this should never leak to the training data, because then you're cheating. And you also shouldn't take the results of that into some of it. But people are doing this. So for example, that's why some of the data sets, we talk about the name entity recognition. It's been here for 20-something years. So of course, every new paper doing this task, well, they didn't train on test data, but they used some information of the performance to improve the model. So it's already sort of cheating. So you're getting better scores. So you're inflating the scores, you're getting better and better over time, because you know what you're optimizing for. You're optimizing for a single test data set. And if you continue this doing for long enough, then you'll reach like 100% accuracy or whatever. Okay, so never touch the test data before whatever, you make a final evaluation, okay? Does it make sense? Sounds great. So let's talk about evaluation of text classification. And this is the simplest example is we have the binary case. So let's say we have two classes, SMIMDB, positive and negative. So we're classifying in a document into those things. And for each example in the test data, so we have this test data, so there's a bunch of documents. So for each of those documents, we are making prediction or inference. So prediction or inference, which gives us some predicted label. Is it readable to some extent? Sorry, my handwriting is horrible. Okay, but if you can read this, that's great. So we have some predicted, predicted label. And of course, we want to predict this, we want to compare this to the actual label. So if we have a document which was actually, the true label was negative, and we predicted it's positive, we ended up here and we add one here to this, and we call this false positive. If, for example, our document was positive and we predicted as positive, we have true positive. So this is 2x2 sort of confusion matrix. And if you run it for all the documents in your data set, you will fill this table with how many times you fall into false negative, how many times you were false negative, false positive, and true positive. I have an example on the next slide. But what is important here, that the ordering of the columns and rows is arbitrary. So you can basically flip these two columns and the meaning will change. So don't try to remember a confusion matrix like left top is true positive, true negative, and stuff like that, because you can just change it and it just won't. You know, you can do it in many different ways, like all the shufflings. So it's arbitrary. Anyways, here's an example of one metric. After doing this, you know, one metric is basically saying accuracy is saying how many times was I correct. It's very simple. These are some very fancy formula saying like for all the documents for all my documents in my test set, if the predicted label matches the gold label, so the I is here, it's not identity function. Oh, I forget its name. It's also I. Anyways, if they're matched, this is going. If they're matching, this is going to be 1. If they're this matching, this is going to be 0. And you're summing up the ones and divide by the number of that. So it's very fancy formula. But what you're doing is that if your documents were predicted correctly as negative, or if they were predicted correctly as positive, which is here, you take the diagonal, sum them up, and then divide by the data set size, by all of them. Okay? It's very intuitive. Like how many times was I correct? In very fancy mathematical way. So an example here of accuracy is, in this example of the confusion matrix, the accuracy would be, so test set size was 286 because 37 plus 48, 33 is 168. And then on the diagonal, 168 plus 37 is some number divided by that. So we have 71% accuracy. So accuracy is something between 0 and 1. If you have accuracy of 100%, your task is solved. But I would say, are you sure? Because if I see accuracy 100%, there is something wrong. I mean, most of the time, like 100% accuracy means like the task is actually super easy. So you don't need any machine learning to solve it or any NLP. Or you just make a very bad mistake somewhere in your setup. And mostly the second is true. Anyways, if the accuracy is 0, then also it's like sort of fishy, because 0 accuracy means like you can, even if you guess, you can be better than 0. So so accuracy should be between guessing, like completely randomly guessing, and 100%. You should be somewhere in between. If you're below guessing, then you screwed up something. Okay, so these are any question to accuracy? Does it make sense? Counting and dividing. How many times you were correct? How many instances was in test data? Good. Now we're getting to something more interesting, which is precision, recall, and F-score. So we'll spend some time on this in the exercise today, just to make sure we understand the concepts, and you try to compute some of those metrics and try to build evaluation as well. So I'm just saying, like the precision is saying, okay, precision, and it's also important to say for which class precision you're computing, because you can compute precision for both classes. So precision for class positive, so we're here, for class positive, is true positive. So how many times was I correct, divided by true positives plus false positives, how many times I predicted positive. So I'm taking this and divide by the sum. So what is it saying? If my classifier is saying 20 times positive, and only 5 times it was correct, then precision is 5 over 20, one quarter. Okay, so how precise my classifier was. Make sense? Good. Because there's another metric, let me just delete this, which is recall. And again, for class positive now, because it will be different for the other class. So for class positive, recall means, again, how many times was I correct? Divided by how many times true positive plus false negative. Oh, how many instances in the test data were actually positive? So if I have data set with 50 positive documents, and my classifier saying is able to find or recall only 10 of them, so then my recall is 10 over 50, which is 1/5. So how many of all the documents which have this class, my classifier was able to identify? So these are two different views. One is more like am I precise in my prediction? And the other is like, am I finding everything which I need to find in my data set? Sort of ish. This is like the mental model you can build, but build your own mental model and do some deep thinking and a couple of examples what it really means. So these are these two metrics, precision and recall. And if I need one single number, this is called F1 score, where I take, and again, for which class? For class positive. So I take, it's a sort of harmonic mean. Harmonic mean of precision and recall. So 2 times PR over P plus R. And it gives me a number between 0 and 1. The higher, the better. But now, what is it doing? It's taking some properties of the data set into account. We'll discuss this in the exercise today, more in detail. Okay? But these metrics are very important. So accuracy, precision, recall, and F1 score are the key metrics to go for any classification. You can go more fancier if you will, like area under curve things, but these are the bread and butter. And of course, you can have confusion matrix. So okay, any questions? F1 score, precision, recall. Sounds doable? Great. I have to tell you one thing. I never remember what is true negative, true positive, true false positive, and false negative. I always, every time I'm looking for this formula, I'll look up for Wikipedia. Sorry. So I won't ask this from you. I mean, you can remember this. You don't have to. I hope. I don't want to promise it's not in the exam, actually. Oh, sorry. I'll try to pay attention to this one. Okay, but you can have this for more than 2 classes. Of course, so this is an example of document classification where we had like 1, 2, 3, 4, 5, 6 classes. And of course, you want to compute how you're classifying on these documents. So there's, you have to make some choices, but eventually you're doing the same. So if you want to take a precision of a trait, for example, or no, that's a bad example. Precision of, let's say, corn classification. So you take the true positive, so how many times corn was classified as corn, and divide by the sum of how many times the classifier said it's corn, and it gives you precision. And recall will be this over all the documents which have the label corn. So you get precision and recall for this class. And then you can take the average of these precision and recall, compute F1 score, and take the average. So if you have multi-class, it's you can do sort of micro-averaging. So the average of F1 scores for each class, or micro-averaging, which is something a little bit different. But these details are, what I'm trying to say, like these details are tricky. So if you are, it's mostly in research or some reporting, like if you do evaluation and you want to report precision recall F1 score, always be very clear which formula you're using and for which class you're reporting what. And at best, there's one very cool paper, quite old now, but it lists all these kind of things. So you might want to cite a paper which actually shows exactly the formulas of these metrics. So, don't leave any ambiguity to the reader, because I don't want to, if I can't figure out, I cannot trust your metrics. Okay, make sense? Good. But this was the easy part, evaluation of classification. And I think, it's not that hard. I mean, if you have to find out, if you have to come up with a metric, you would absolutely come up with accuracy. Like how many times was I correct? Makes sense. This is very intuitive. But how about text generation? Well, that's going much trickier. So evaluating text generation is hard. This is just a part of a table which is a survey of evaluation metrics used for natural language generation systems. Not that old, 2 years ago. And this is just the first quarter of the table. So it's a long table. And the reason is like it highlights all these different metrics you can use for language generation, for which task you can use them, and what are them some other properties. So this survey is, if you're interested in that, I would really suggest to look in the survey. And it's active research idea. Why? I mean, basically, we saw this example with machine translation. You have so many different true answers. Then you have to say, like, if I translate the sentence, do you remember the sentence, by the way? Je suis things, I don't know, something in French. into something very weird in English, like, how do you know you were correct? So maybe you have some references. So you have some reference translations for your sentence. And the hypothesis is something which is coming out of your system. So you want to compare the hypothesis and the references. So one of the very early scores is called blue, which sounds French. So does it sound French, blue? No. Yeah, it does? Okay, cool. Because there's another one, and then you will understand why I'm saying this. So there's references and hypothesis, and you want to compare these two together. And this is the number of overlapping n-grams. So what is an n-gram? It's a n-gram. Do you know what an n-gram is? Everybody knows what's an n-gram? Who doesn't know what is an n-gram? Okay, n-gram is just a couple of words after each other. So 1, 2, 3. This is a trigram. Okay? 1, 2. How is this called? A bigram. Bigram. How is this called? Unigram. Yes, unigram. Unigram. And so on. And 4 gram, 5 grams, 6 gram they're not used basically, but it's just a consecution of words. So, and now the blue score is taking the hypothesis and the references and comparing the overlapping n-grams with respect to the total number of n-grams in the hypothesis. So n is a parameter, so we might use 2 grams, 3 grams. And you're seeing like, oh, are my words which are translated matching some of those in the references, regardless of where it is in the sentence. Because some sentences, in some languages, you might start like subject, verb, object. In some sentences, you have some verb at the end, but at the end, but the shuffling of the sentences or the word order in sentences might not actually matter that much, but the overlap of n-grams matters. So that's what you're computing, the overlap of the token sequences between your translation and the reference or references. There's a couple of references, so it's always like global. So it's corpus level metric because it gives a score over the entire corpus as opposed to scoring individual sentences. So you do this for every hypothesis and every reference. You're computing the overlaps. And the major drawback of blue is it's a precision based. So if you're matching the tokens, that's great. If there's more tokens, it's ignored. So if there's no more tokens in the reference, you don't count this. So, which means there's another metric. The first one was blue. Can you read this one in French? Rouge. Okay, so I don't know why they choose like French names for metrics, but there's two ones, blue and rouge. So it was. I asked this in the exam. Like, can you name 2 basic metrics for evaluating machine translation? Most of them was like blue and rouge with spelling errors, and somebody wrote like red and blue. Fair enough, full points. I get it. I don't speak French either, so yeah. But don't call them red and blue. I mean, these are blue. Rouge, which is orange, I guess, or red and blue. Which means recall-oriented understudy for gisting evaluation. I think they just made it up to make it like sounds French because the blue sounds French as well. So, anyways, this is the opposite of blue. Basically, it's taking the n-grams but counting matches. So it's a recall-based metric. I think we have some examples of playing around. So I'm not showing the exact formula because it's kind of not super important, and obviously you don't want to develop these metrics from scratch by your own. There are some packages, but in the exercise we have some assignments for playing around these metrics, so you understand how actually machine translation is evaluated and what are the trickiness of that. Okay. Any questions to blue and rouge? Okay. So why is this tricky? For example, there's as you saw, there's a research on evaluation. What are some caveats of benchmarking NLP? So, for example, is blue a good metric? Because blue was originally proposed for diagnostic evaluation of machine translation systems, which allowing researchers to quickly weed out bad ideas from good ideas. So, blue wasn't designed for evaluating a real system. It was like, yeah, if I develop a system, I can just quickly evaluate automatically. But the real evaluation maybe should have been done by putting things in production, having real people evaluating the translations, runtime, or whatever. So blue is not really a great metric, because if you compare blue to human evaluations, Sometimes they correlate a lot, sometimes they correlate a little. So there is a wide range of correlations. And that's why blue should not be the primary evaluation technique, in papers. I mean, if you write a paper on machine translation, you should have blue as well as a very baseline technique for evaluation, but you should have something else, like some modern, let's say, transformer-based evaluation techniques. You might look it up in this paper, for example, and there's implementation you can use out of the box. So, because it's hard, there's so many options. How can you evaluate things? There's very many opinions, and some are better, some are worse. The second difficulty in evaluating NLP in general, for example, if you go to classification. So what could be what is the challenge of classifying? What is the challenge of labeling a text? So where do you think people might disagree on labeling stuff? If I'm gonna give you a task, like I have some data points, can you label them? Where do you think people will struggle to have a good yes? Yeah, what is a decision board? I mean, you're talking in machine learning terms, like about I'm giving you a bunch of texts. What can you imagine scenarios where this will be actually hard to label?
For example, when we have to decide like the name, type of sounds, like name you would give a female child or a male child.
Okay.
But we have in German like several names which are used for female and male child.
Okay, so exactly. So so if you were to classify, if you want to label names based on gender, where you binarize the gender into male and female for your use case, and there's names which are ambiguous. So this will be hard. Okay, good. This is hard by design, but because these names are not ambiguous. But is there any other scenario where it's actually the text might be clear? Yes? Rating, yes. Okay, yes. Like assigning stars to some reviews. You mean? Yeah. Okay. Okay. Yeah. So there's exactly. So these are the hard ones. For example, I'll give you another one. Toxicity of comments, which is which is a thing you will never want to do for free or for being paid. So social media companies, at least Facebook, what I remember, they need to classify toxic comments and delete them for, I don't know, racism and all these kind of creepy stuff. So they outsource this, and annotators annotate comments for being toxic or not, which is a binary decision. But how do you know a comment is toxic? Sometimes it's very clear. Sometimes it's actually very subjective, and you need to understand very a lot of the context and also your own biases to say whether something is toxic, whatever it means, and what not. So it's very subjective, and it's actually very hard. And the question is here, we had this gold data paradigm, like there is a ground truth that makes sense, humans agree, but sometimes it's easy, like does this image contain a bird? Yeah, yes, no. Is learn a verb? Yes, no. Is name male or female? Oh, actually might be a little trickier. Is this comment toxic? Oh, yeah. So there's a human label variation, and we don't know what to do with this. I mean, it could be an opportunity. It might be, it's considered as a problem where you have when you don't have one single true answer, and we're trying to try to neglect it and take everything as one category. But there's an active research on this, let's take the variation. For example, we have this in the legal domain, where two experts, are annotating the same stuff, and they actually both are right in the way they annotate it. So there is no disagreement. There is just different interpretation of the thing, and given the legal system, both make sense. And now we're struggling okay, what shall we do with that? So that's kind of tricky. So sometimes there is no gold standard data. But for the sake of education in this course, we will assume everything, if we do classification, everything is kind of binary or categories, and everything is simple. In the real world, it's actually quite tricky. And new benchmarks are coming in all the time, because you wanna see how well your models are performing. There is one benchmark with just very horrible name, Humanities Last Exam, data set. So it popped up, I think, like earlier this year. The latest version is like last month. And it's 2,500 challenging questions compiled by experts in their domains. It should be like PhD level questions, and you cannot just Google for them. Like there's no answer. You have to know a lot of stuff to answer these questions. That's what the people are saying. So here's an example. Question. Hummingbirds with I can't even read this. Apodiformes uniquely have a bilaterally paired oral bone. A sesamoid, what? I can't even read this. I mean, so you want to try your fancy LLMs to try to answer these questions. This benchmark is actually like multimodal. So there's some images understanding, math, equations, physics, and things like that. And what they're evaluating is accuracy of these answers. So the metric is kind of what you know. And here's an interesting example. So they compare to some sort of math questions, MLUs like language understanding, some tasks. And you see like the models are getting over time better and better, getting like 80, even 90%. So it seems like all these tasks are solved. And what these authors are claiming, okay, these questions are so hard, excuse me, that even like, GPT-4 5, whatever, they just can't solve it, and the accuracy is just horrible. And what they're saying, like, if AI will solve these questions, then we need to turn off the Skynet or something like that, So I don't know. It's up to you. I mean, AI is here. It will be here. We should understand it, and we should be careful about like doing research, deploying stuff, and also be careful about making statements like this bloody title of humanity's last exam. It means like if this is solved, like humanity is done. Oh no, come on! Like it's a very bad title. But the data set is kind of cool. And the question is like, okay, which models are coming here that will get like 89%? And I guess it's not impossible because of what I said, like data contamination. Yes, never train on your test data, but it happens. So this is a very cool paper by Simone Baluku, who is now actually a good friend of mine in Darmstadt now, but he did it in his postdoc in Prague. So data contamination means that you evaluate LLMs on the same data they were trained on. And what Simone and colleagues did is they look into research on where people used data sets and basically put them, try to avoid the data sets or the task on closed source models like ChatGPT through API. And it showed like the performance on these tasks went up over like a half a year or a year. So what happened is if you ask ChatGPT to solve your task and put your test data to the model, maybe with some instructions like, oh, this task is about this and this, solve this, you are exposing your test data to OpenAI. What OpenAI is doing, it's collecting all the data you're putting in every month and add it to their training. So they're training the model on whatever they see. So of course, after half a year, it has seen like one of these 90 papers like 99 times, 90 times the data set. So it just trained on the data. So can you then you get better performance, but you have no clue why. Most likely it's because data contamination. Data contamination is a big thing. Like people are making claims, ChatGPT can solve A, B, and C. And the question is, yes, but how do you know this particular example was not in any training data for ChatGPT? And the answer is like, you don't know. Because it's OpenAI, it's like closed AI. They don't say anything about their training data, anything pre-training. You have no clue what's in ChatGPT's data. So it might be as well your test data. And your claims like, oh yeah, maybe it's solving the humanity's last task. But maybe somebody put this humanity's last task to GPT-4 like in full, and then wow, voila, 100%. Maybe, I don't know. I mean, you cannot prevent this because you don't know what's OpenAI doing. So what Simone is making a call here is like if you do research and want to be very precise on what you're doing, you should use open source models like open. Pythia, Olmo, is Olmo open source? I guess Olmo, Bloom, a little bit Llama, but Llama is tricky. You know why Llama is tricky? Because you don't know what is pre-trained. They were stealing data. You know where from? They publish the model, it's open weight, but you don't know the pre-training data. So it might be you don't prevent like data contamination because you have no clue. And people are trying to find out by prompting the model what's in the pre-training data. It's possible. So Ahmad, one of my PhD students, like doing membership inference attacks on books, try to find out which books were in the training data of Llama. And they were stealing books from Zlib. Have you ever heard of Zlib? I never heard of Zlib. Okay, I don't want to put this on YouTube, sorry. No, yes, of course, they were just stealing data. And there's a court case, and I don't know how it ended up, maybe, I don't know. So, yes, you know?
Yeah, the Supreme Court ruled for Anthropic that they could steal books.
It was Anthropic, but Llama was a different story. It's like in parallel. So Anthropic was also stealing data. Case law.
Case-based, so they...
US is case law, so maybe they will say like, yeah, you know, so there's, yeah, Anthropic, yeah, they made it through for, what was the reason? Fair use. Yeah, if you steal all the books, it's fair use. And train your model and sell it. Nice. I don't know, I'm not a lawyer. Anyways, yeah. So data combination is a real danger for anything serious. Good. We made it on time. Recap, short recap. We set up the scene. NLP is challenging. I believe now you're with me that NLP is really challenging. There's vast amount of tasks and data sets. Data quality matters. We need to understand the data, annotators, and tasks. We get familiar with some common evaluation metrics. And getting better scores is just the beginning of the story. And evaluating generation is really, it's an art, so it's active research. So, any questions remaining? It's not okay, so thanks a lot. I'll see you at 2 in the basement. Thanks.